Here are some common pitfalls when working with matrices. The first is attempting to create a matrix does not have the same number of values in every row. That would be an error. So you always have to have the same number of values in every row of a matrix. Another pitfall is confusing matrix multiplication and array multiplication. Array operations, which include multiplication, division, exponentiation, addition, and subtraction, those are all performed term by term or element by element, meaning that the arrays have to have the same size to begin with. The operators involve putting a dot in front of the operator. So dot asterisk for multiplication, dot slash for division, dot and the exponentiation operator. So this is, again, array operations. For matrix multiplication to be possible, the inner dimensions have to agree, and the operator is just the asterisk. So again, for array multiplication, the arrays, meaning vectors or matrices, have to have the same dimensions, and that means just multiplying corresponding elements, and that's the dot star or asterisks. For matrix multiplication, in order to be able to multiply the two matrices, the inner dimensions have to be the same, and the operator is just the multiplication operator for matrix multiplication. Another common pitfall is attempting to use an array of double ones and or zeros to index into an array. It can't be the type double, it has to be the type logical, which is what you would get if you used one of the relational operators. Another potential problem is attempting to use the scalar or the scalar and operator with arrays. You always have to use the single vertical line and the single ampersand when working with the arrays. The double vertical line, the double ampersand, those are only used with scalar operands. Here are some programming style guidelines. If possible, try not to extend vectors or matrices. It's not efficient at all. So sometimes it can't be avoided, but if it can be avoided, don't extend vectors or matrices. It's also much better to use subscripted indexing rather than linear indexing when referring to elements in a matrix. So don't just use a single index, meaning linear indexing. Instead, use both the row and the column indices, which is called subscripted indexing. In order to be general, you should never assume that you know the dimensions of any array, either a vector or a matrix. Instead, when you have a vector, use either length or num_L to determine the number of elements in the vector. And when you have a matrix, use the size function to get both dimensions, the number of rows and the number of columns in a matrix. So typically with a vector, you'd store the length of a vector in a variable. With a matrix, you would store separately the rows and the columns, the number of rows and number of columns in a matrix. So when you use the size function, you put that in an assignment statement that has two variables on the left. So you're actually capturing both the number of rows and the number of columns in separate variables. Also, it's better to use the built-in true instead of logical 1 and false instead of logical 0, especially when you're creating vectors or matrices.